Hi there! Welcome to my talk at Laracon EU Online. I'll be presenting Deploying Laravel with Ansible. I'm Erika Heidi. I work as a DevOps technical writer at DigitalOcean. I am very enthusiastic about Linux, open source, and automating all the things. I worked most of my career as a PHP developer, but also have a strong background in systems administration. And I wrote a book called Vagrant Cookbook. I also have some open source projects that are related to configuration management and Ansible. And you can find me on Twitter. I'm Erika Heidi there. Let's set some expectations about this talk. This talk will be very focused on the end goal, which is to deploy a Laravel application to a remote Ubuntu server using Ansible, using one Ansible playbook. And I will abstract the part where we set the LAMP server. This can also is also available on the repository that you have access. But this talk will be focused on the end goal, which is to run this demo. So we will start by revisiting Ansible terms and architecture, then we'll learn how to run playbooks, and then we'll see some advanced topics about Ansible playbooks, running Ansible playbooks, group variables, and Ansible vaults. And then we will be able to finally run the demo. So let's get started right away. Ansible overview. Ansible is a Python-based tool that can be used to automate server setup. It is agentless, which means you don't need to install any special software on the nodes that you are going to install. Ansible uses SSH and Python to run the commands on the remote servers. You only need to have Ansible installed on a machine that will be your control node or your control machine. This can be a remote server, or it can be also your regular working machine. It has an idempotent behavior, which is a common feature from configuration management tools, and that means it will always reach the desired state at the end of the execution. It won't necessarily run all the tasks because it's not going to repeat itself. So if something was run before, if a state was reached before in a different way, it won't be executing the task again. This gives a lot of performance improvements and makes it faster and so on. It uses YML to define the automation, which is very accessible. Most developers are used to that. It has a sequential execution of tasks, which means that what you see in a playbook is what you get. The order is exactly the same. The order where the tasks are executed is the same where you see in the playbook. It has hundreds of built-in modules. There is a module for everything. There's a module for Composer, for instance, for installing, updating Composer. And some of these modules will require that you install a package beforehand. So for the Composer module, for instance, you need Composer globally installed before, but this can also be automated in another task, so it's not a problem. It uses a templating system from Python called Jinja 2, and it can be extended in any programming language able to return JSON. You can create plugins, modules, you can create dynamic inventories. I have created dynamic inventory with PHP in the past. It's very good and it's very handy. So the terminology that we need to be used to when talking about Ansible. The control node I mentioned before is the machine where you have Ansible installed. It can be your local machine, it can be a remote server. You have the managed nodes. So these are the hosts that you are going to control using Ansible, and these are listed in an inventory file. The inventory file is where you have all your hosts, and you can have groups and subgroups in the inventory file. Modules are a collection of similar functionality Let's say you have a module for installing packages, you have a module for using the template system, you have a module for running Composer, like I mentioned before. You can also create your own modules. A task is a minimal unit of action that you're going to execute on a remote server. Handlers are used to manage services such as web service, restart Nginx, restart PHP FPM, restart the database, or stop a service, and so on. A playbook has a collection of tasks and can also has variables and a few other directives to specify details about the execution of that playbook, where it's targeted, and so on. Roles are a collection of templates, files, and playbooks, any other files that are related to accomplishing a goal. Let's say install Nginx or install PHP FPM, install MySQL. So everything that is related to that goal, it's going to be together in a folder in a certain way, so that Ansible automatically loads those files. Some of those files are automatically loaded by Ansible. So how do we connect to nodes? Once you have your control node set up, Ansible installing everything, you have to create an inventory file with your managed nodes, the hosts that you're going to control. The inventory file is typically in INI format, and you can create groups and subgroups of servers there. Let's see an example. This is a basic example. It has 2 groups and a subgroup. I have a development group, a production group, and I have a servers group, which is actually a subgroup, children group, which is composed by development and production groups. At the end, I have the all vars definition here, and this is used to set up variables that will be valid for all hosts on this inventory. In this case, I am defining the Ansible Python interpreter variable, and this will make Ansible use Python 3. Make sure Ansible uses Python 3 when running the commands on the nodes. This will execute a test command, a ping command to test the server's connectivity, and it will also test if the nodes are able to run Python commands. So Ansible all. So I'm telling Ansible, I want to run this command on all hosts from my inventory file. I'm passing the inventory file, call it inventory, this is the name of the file, and then I use the -m to call a module. So I'm using the ping module here. And optionally, I can use the -u or other connection parameters to be able to connect to the servers. So in this case, when you create new servers, usually you only have the root account. So you might need to provide these -u root so that you can connect initially and run a initial server setup playbook, for instance. This is the output. So you will see success and success, and that means that you are able to connect and run playbooks, so we can move forward. Once you have you are able to connect and run commands, you can run playbooks. So let's see what playbooks are and how to run them. Playbooks can target single servers or groups of servers, and they can use features that make the playbook look more like a code, like programming language, because you can use variables. For instance, they can be inside the playbook or they can be included from external files. Facts are like global variables with information about the system. Loops, you can use loops to execute a task with different values, the same task with different values, like installing a package. instead of installing just one package, I will loop through the task and install an array of packages. You can use tags to filter the execution of a playbook and execution time. You can use conditionals and blocks. So it is common, it's handy to have like a condition. Let's say if this command is not installed, then run this block of tasks. So this is how blocks are often used. You can include other task files to organize better your playbook. And you can also use roles to have things really well organized and make it easy to reuse them later. This is an example of a playbook to install a few packages. You start with the YML notation and then you have the start of the playbook. So you can notice here that actually this is a list. So you can have multiple playbooks in the same playbook file. And while this is possible, I don't recommend it. Things can get a bit messy that way. But yeah, so we start with this and then hosts all. So you tell Ansible to execute these on all hosts from your inventory file. And then you have become true. Become is a privilege escalation directive. So you're telling Ansible to run all these tasks using sudo. In the past, this was called sudo, but in recent versions, it changed to become. So that is more abstracted, let's say. Vars is a section where you can define variables. So I'm defining here a variable called syspackages. It's an array and has a few different packages. And then I start with the tasks. I have just one task here. It's to install packages, and it uses the apt module to install the packages that I defined in the vars, in the variable syspackages. So this will make Ansible loop through the task using all these different values. It also has the update cache. This is an option. Each module has its own options. So the apt module has this option to signalize that you want to run the apt update before installing these packages. Okay, so this is an example of running a playbook. So you have the Ansible playbook executable, then you provide an inventory file, your custom inventory file, then you say you provide the playbook name, and then you can provide additional connection options. In this case, I am providing a user option to connect as root, and then you see the output from the execution. So both servers, I have two servers in this inventory file. And then when you install the packages, you see that there is a change. So a state has changed on the servers, and this is going to be outputs for you. Okay. Some additional options when running playbooks. If you don't want to run, you only want to check what would be executed, which hosts would be the targets, which tasks. Then you can use these options: list tasks, list hosts, list tags. The verbosity settings are very useful. If you are having trouble with connection, then you should use -VVVV, and this will give you detailed information about SSH connection. So this is how you will find your problem if you're having trouble connecting via SSH. To control playbook execution, you have some options: tags, started task, and skip tags. They are kind of self-explanatory. Okay, so let's see a few advanced topics before we can actually go to the demo. Group variables are very useful for multiple environments. So let's say you have a production group and a development group, and then you want different credentials, which would be completely normal, expectable, that you have different credentials for the database in each environment. So you can use group variables for that. So this is how it works. You have a directory called group vars, and inside this directory, you will have a file called all.yml with the default values. So all the default values will go in this file, all the default variables and values. And the other variable files you will create there will override these default values, and these will be per environment. Let's see an example to make it more clear. So I have this inventory on the left. I have two groups, development and production. On the right, I have the all.yml file, which is a variable file. This will be automatically loaded by Ansible. And then we have remote user, MySQL root, server root, and document root. We have 4 variables here. And these are all development values. Then I create a production.yml file with only the variables that I want to overwrite. So this will be, they will have a higher precedence, and then we will overwrite the default values I defined in the all.yml file. So you can have your custom credentials here for the production environment. And then you can have as many as you want. This will have to be based on your groups, of course, the groups that you have set in your inventory file. And well, you set up a variable file with MySQL credentials for your production server. How do you commit this to your repository, right? So they cannot be in plain text. That is why you have to use Ansible Vault. So Ansible Vault is used to protect sensitive data in Ansible playbooks. You can encrypt any file, really, but typically you will be encrypting the variable files because those are the files which contain sensitive data that really needs to be encrypted. To encrypt the file, you can use Ansible Vault Encrypt, and then the file that you want to encrypt, it will prompt you to provide a password and to confirm the password, and then it will be encrypted. So anytime that you are going to run that playbook again, you will need to provide the Ansible Vault password. You will have to provide an extra option, -- ask vault pass. And then Ansible will prompt you to provide the vault password. I have a demo here. So first you can see the value of the raw file, production.yml file with all these credentials in plain text. Then I will use Ansible Vault Encrypt and provide a password. And now the file is encrypted. So if you cat it again, you will see that it's all encrypted. Okay, so now you can include this on the repository. The commands, the Ansible Vault commands, these are all of them, I think. So create, it's for creating a new encrypted file. Encrypt, it's for encrypting existing file. And then you can use the view commands to visualize the contents of the file. And then you can use edit to edit and change the values. And you can use decrypt to permanently decrypt a previously encrypted file. Okay, so we saw how to run playbooks, we saw how to use group variables, and how to use Ansible Vault. So now we can proceed to the demo part of this talk. And First, let's see what is this demo. So it's a very basic demo. It's a travel list application. It's like a to-do list, but it's for traveling. So for places that you want to go or that you already visited. And it has a few images as well. What we are going to do is we'll see first which tasks are necessary to deploy this application to a LAMP server, and then we will see the actual Ansible tasks for each of those requirements. So what we need to do, first we need to create a document root folder. Then we will need to synchronize our application files, local files, to the remote server. Then we will have to set some special permissions for the user www data on the storage folder. So this the web server user can write on those directories. Then we will set a .env file that is based on a template for the Laravel application. Then we will install application dependencies with Composer. And then we go to the artisan commands, generate the application security key, set up public link to storage folder, and finally run database migrations and seeds. Our first task then will use the file module to create a directory on the remote server. So this is the path. We want it to be a directory. We set the mode. We set the owner and the group, and these are all defined in a variable file. The remote user is our system user, is a user with sudo permissions. So it needs to be that way because we will need this user to run composer commands, artisan commands. We cannot use the www data for that. It's not safe and it's not recommended. So we have to use a system user, a regular system user for that. Now we are going to use the synchronize module to rsync the application files to the remote server. This uses rsync to synchronize the files. So the actual playbook has a few other options here to ignore some directories, but this is basically it. The source and the destination, and it will send all the files. Next, we will set up some additional permissions with the ACL module, which is like using setfacl, the command, to provide fine-grained permissions to the www data user so it can write on the storage folder. There is in the actual playbook an additional task like this for the bootstrap folder, which also requires this user to be able to write that. So when you clone the repository to run a demo yourself, you'll see that there is also a task like this for the bootstrap folder. Then we will set up the .env file based on a template, and there are other ways to set this .env file, but this is the simplest way. Using a template, Ginger2 template, and you can set up variables there and do whatever you want. So the variables will use values defined in your variable file. So you can change these values easily from environments. So from development to production to staging or testing, you can create a variable file for each environment and have your .env Laravel file set up using a template. Then we will use Composer, use the Composer module to install the application dependencies. As I mentioned before, you will need Composer to be globally installed first. So this is on the LAMP playbook that I'm not showing here to keep it short, but you will have access to that playbook as well in the GitHub repository that contains the demo. When running the composer module, using the composer module, you will tell the command that you want to use, in this case install, and the working directory. You see here that I set up a tag here, composer install. So this is because you might want to run this again a few other times, and you don't need to execute the whole playbook. You can only execute this specific task using the tag. Then we go to the artisan commands. Generate the application key. And I'm using here the command module. This is to execute arbitrary commands, any command you want. So you can use this. Then I'm using PHP, a variable here that contains the application root directory and artisan key generate. Also setting some tags here if you want to run only this task. Then we go to the storage link. This will generate a link, a public link to the storage folder because we have some images there. And finally, we have the task to run migrations and seeders. So this will populate the database, create the table, and populate the database with sample places. And you can also, you have some tags as well to run only this task if you need. And that is all. So we are now going to run this demo and see what happens. So the demo is available in the repository, the O community Ansible Laravel demo, so you can use it later to run the demo yourself. And our servers now, they have a LAMP server installed through another playbook that is included in this repository, but they don't have the application set up yet. So this is what you get now if you go to the browser. We will now run the Laravel playbook. So Ansible playbook, and then the inventory. Oops. Yes, so the remote user is Sammy. Okay, so make sure the remote app root exists, rsync, directory permissions, and then set up the .env file, and we are now on the composer install, which is the task that will take longer in this playbook. Well, if you when you run it again, because the vendor folder is already there, then it will take a lot less time to run the playbook, but the initial run will take a bit longer. The good news is that it runs in parallel on both servers, so it is not going to take longer because you are running on two servers at the same time. And also, on like how I mentioned on the slides, you should have a separate variable file. Make sure you have the production variable file and all that, as we talked in the slides. And then you can deploy as many servers as you want at the same time. Okay, so one server is okay, the other two, and then the other tasks are really fast. So if we go to the browser now, the application should be up and running. Let's see. Yes. So this is one, and this is the other one. Okay, so it works. And So this is it. If you have any questions, you can reach me out on Twitter, and you can find all the materials for this talk, the slides, and also the repository containing the demo in this link. I hope you have enjoyed this talk. Thank you, and see you next time.